Malaysian Prime Minister Najib Razak has confirmed that part of the aircraft wing found on Reunion Island is from the missing MH370 plane. Mr. Najib Razak said experts examining the debris in France had conclusively confirmed it was from the missing aircraft.
A very heavy heart that I must tell you that an international team of experts have conclusively confirmed that the aircraft debris found on Reunion Island is indeed from MH370.
The Malaysian Airlines plane carrying 239 people veered off course from Kuala Lumpur to Peking on the 8th of March 2014. The debris was found on the remote Indian Ocean island Reunion and was taken to Toulouse for testing. The plane is long believed to have crashed into the southern Indian Ocean, though no evidence had been found despite a massive search operation. Now the discovery of a flaperon from one of the wings raises the hope of solving one of the greatest mysteries in modern aviation. The Malaysian Airlines Flight 370 was a scheduled international passenger flight that disappeared on the 8th of March 2014 while flying from Kuala Lumpur International Airport to Peking Capital International Airport, China. Flight 370 last made voice contact with air traffic control at 01:19 am Malaysia Standard Time when it was over the South China Sea, less than an hour after takeoff. The aircraft disappeared from air traffic controllers' radar screens at 01:21 am. The aircraft, a Boeing 777-200ER, was carrying 12 Malaysian crew members and 227 passengers from 15 nations. One Indian passenger, Chandrika Sharma, was also on board the ill-fated flight. The disappearance of Malaysian Airlines Flight 370 has been dubbed as one of the greatest aviation mysteries of all time. So what happened to MH370? On the ill-fated day, March 8, 2014, Captain Zahari Ahmed Shah and First Officer Farid Abdul Hamid sign in for duty. At 0000 hours, Boeing 777's satellite data unit logs into Inmarsat communication network. At 040 hours, air traffic control of Kuala Lumpur International Airport gives clearance to take off.
Delivery MH370, good morning. MH370, stand by, squawk 2106. MH370, request level. MH370, we are ready, requesting flight level 350 to Beijing. MH370 is clear to Beijing via Bypass 6000 feet, squawk 2157. Ground MH370 requesting push and start. Push back and start, approved. Runway 32R. Line up 32R, 810, MH370. MH370, 32R, cleared for takeoff.
MH370 departs from Kuala Lumpur International Airport at 0041 hours, Malaysian Standard Time. At 0042 hours, ATC gives Flight 370 clearance to climb to 18,000 feet and proceed directly to waypoint IGARI.
Okay, flight level 190, direct IGARI, MH370.
In aviation, a waypoint is a reference point in physical space used for purposes of navigation, otherwise known as a landmark. At 0050 hours, 8 minutes after takeoff, air traffic control gives Flight 370 clearance to climb to flight level 350, approximately 35,000 feet. At 0101 hours, the crew confirms that the flight is at an altitude of 35,000 feet. Everything seems well and good till this point. Another routine flight for Captain Ahmed Zahiri and Malaysian Airlines. At 01:19 hours, Kuala Lumpur ATC instructs the crew to contact Ho Chi Minh Air Traffic Control, which is in Vietnam. Now the captain has to tune into the radio frequency of Ho Chi Minh Air Traffic Control. This is not unusual in aviation, to have a radio blackout for a moment in this handshaking process. The aircraft passes waypoint IGARI. As the captain replies,
Good night, Malaysian 370.
this is the final voice contact with Flight 370. An aircraft communicates with the secondary surveillance radar using a device called transponder. A transponder produces a response when it receives a radio frequency interrogation. Aircraft have transponders to assist in identifying them on air traffic control radar and collision avoidance systems.
Every aeroplane is equipped with a transponder. The transponder is an interrogator. When the airplane takes off, the air traffic control gives a specific number, which they put it on their aircraft. Now, then the radar and the aircraft interrogates each other, and on the surveillance radar, you will get a number. You don't see an aeroplane, but you see the number. You squawk that number.
At 01:21 hours, the position symbol of Flight 370 disappears from Kuala Lumpur ATC radar, indicating the aircraft's transponder is no longer functioning. To turn off a transponder, a pilot has to turn a knob with multiple positions and select the off setting. But a Boeing 777 aircraft has a backup transponder.
In an aeroplane, we have a fail-safe system that if one system fails, the second one takes over.
But the second transponder doesn't automatically activate if the first one is shut down. In this case, it appears one transponder was turned off and the second not activated. The final data from the transponder indicated the aircraft was flying at an assigned cruise altitude of 35,000 feet. There were few clouds around this point and no rain or lightning nearby. Later analysis estimated that Flight 370 had 41,500 kilograms of fuel when it disappeared from secondary surveillance radar. Now that both the transponders are off, the only way to locate an aircraft is using a device called a primary radar. Primary radar, sometimes called skin paint, works on the principle of bouncing high-powered microwave pulses off objects and detecting the reflected echo.
Radars, they shoot out a signal, beam, reflects on the aeroplane. It comes back, and the antenna at the station catches it. Basically, these primary radars are used by the defense forces.
Meanwhile, Malaysian military started tracking Flight 370 using its primary radar. Malaysian military radar continues to track the aircraft, which almost immediately begins to turn to the left until it is travelling in a southwesterly direction. The last primary radar contact is made by the Malaysian military 200 nautical miles northwest of Penang. Even if an aircraft transponder has been disabled, its most basic system, such as engines, can also send status information back to ground stations, including the engine manufacturer or the airline. All modern airliners are fitted with a modern communication system called ACARS, which stands for Aircraft Communications Addressing and Reporting System. ACARS on the aircraft send manual and automated text messages from the aircraft back to base and vice versa. Along with general information about the flight, call sign, speed, altitude, position, etc., these messages may contain what we can consider systems health checks. Normally, ACARS doesn't send an actual location. It sends essentially system data. It doesn't indicate altitude or direction, but as long as it's pinging, you know the airline is not down.
ACARS actually transmits the data of the aircraft on radio frequencies, of the performance of the engines, of the performance of the fuel, of the performance of various other aspects through to the communication center of a particular airline.
ACARS is able to send messages using a system of satellites that are run by the British satellite company Inmarsat, which is perfect for an aircraft at sea, as it removes the limitation of needing to be close to ground-based transmitters to send radio messages.
Inmarsat is a group of satellites, with a network of satellites. It is being used by some aircraft manufacturers and some component manufacturers, specifically engine manufacturers, to communicate, to give the performances of the engines.
The thing that made MH370's disappearance all the more mysterious was that its ACARS system was also switched off. The fact that the ACARS messaging system shut down along with the transponder raises crucial questions. Without informing the ground-based control, the pilots are not authorized to turn these critical systems off. Although this is unusual, it is not hard to do. The switch is located either on a ceiling unit or on the deck between the pilot and co-pilot, down behind the throttles. Perhaps a mechanical or electrical failure in the aircraft could have disabled the transponder and ACARS. But Boeing 777 has an impressive flight record of 20 years. Even in case of mechanical or electrical failure, the pilot would have initiated a distress call and should have attempted an emergency landing. But that did not happen in the case of MH370. The aircraft went straight to the roaring 40s. At this point, we don't know who was in charge of the flight, Captain Zahari or the autopilot. While the primary ACARS system on board MH370 had been switched off, a vital link kept going. A second ACARS system called Classic Aero, which operates independently of the switches in the cockpit and gives handshake signals or pings with the Inmarsat network at regular intervals to synchronize timing information.
Now, it is something which is not mandatory. An aircraft might or might not have an ACARS system built on it. There are certain components of the aircraft which do handshakes with satellites on regular intervals, such as engines.
There is no way that a Classic Aero can be switched off unless the plane itself loses power. These pings kept going for 6 hours until the last communication with the aircraft. At 2:39 am, ground-to-aircraft telephone call via the aircraft satellite link went unanswered. At 6:30 am, flight missed scheduled arrival at Beijing Capital International Airport. Malaysian Airlines issues a press statement announcing that Flight 370 is missing. At 8:11 am, the last successful automated hourly handshake with Inmarsat satellite happens. Disappearance of a commercial airline in such an unusual manner is unheard of in the history of aviation. The mystery deepens. Modern commercial airlines are equipped with state-of-the-art avionics and standardized operating procedures. But MH370 topples every preconceived notions and precautions in aeronautics. What baffled the investigators was not the disappearance itself, but the way in which the aircraft had disappeared. An unparalleled chain of events transpired in making the flight vanish into thin air. From the moment news broke that MH370 had gone missing, the world's conspiracy theorists have weighed in with explanations of their own for the aircraft's disappearance and for investigators' continuing failure to find it. The subsequent crash of flight MH17, shot down over eastern Ukraine last summer, added to speculation, while a lack of clarity from Malaysian officials about the earlier mystery allowed rumors to flourish. The only trace that MH370 left to probe was the handshaking signals with the Inmarsat satellite. The day after the accident, staff at Inmarsat reviewed the log of communications between their network and Flight 370 and discovered that Flight 370 continued for several hours after contact with air traffic control was lost. On 11th March, they provided a preliminary analysis to investigators based on recorded burst timing offset BTO values. BTO, as recorded on the Inmarsat satellite, is a measure of the time taken for a transmission round trip, ground station to satellite to aircraft and back, and allows a calculation of the distance between the satellite and the aircraft. Relatively simple calculations can be made from BTO values to determine the distance between the aircraft and satellite at each transmission. When these distances are plotted on Earth, they result in rings, which are further reduced to arcs due to the limited range of the aircraft. These arcs can be in the northern or southern route. Another value, burst frequency offset, BFO, was analyzed to determine the movement of the aircraft relative to the satellite based on the Doppler shift of the signals, which provides the location of the aircraft along the BTO-derived arcs. Doppler effect. The Doppler effect is something we are familiar without even knowing it. The sound of the ambulance's siren or the train whistle are among the most common examples of how Doppler effect works. The high pitch of the siren of an approaching ambulance suddenly drops as the vehicle passes you. Since satellite pings are carried on a radio wave, the sensed wavelength, frequency, increase or decrease depending on the fact that aircraft is moving towards or away from the satellite. The difference between the expected received frequency and the actual measured one due to Doppler effect is known as burst frequency offset. By comparing the burst frequency offset due to Doppler in MH370 against the predicted one based on 6 Boeing 777s flying on the same day, Inmarsat could determine close correlation for the southern route and eliminate the northern one. In the series of handshake signals, the 7th one had a unique fingerprint. It was the last one and a partial one. The last and 7th handshake at 8:19 am was a log-on request initiated by the aircraft and is believed to be the result of the satellite data unit starting after power failure, resulting from fuel exhaustion and following the deployment of the RAM air turbine and restart of the auxiliary power unit. The BFO value of this handshake indicates the aircraft may have been descending and the aircraft was traveling northeast to southwest. Knowing the location of the 7th handshake, investigators then needed to determine an appropriate width of the search area. The discovery of the flaperon in Reunion Islands from the missing flight now raises the hope that the mystery will be solved eventually. Use of satellite handshakes to determine the position and search area of a missing flight is unprecedented. Such a humble piece of data becoming the pivotal piece of evidence in aircraft disaster investigation is unparalleled. The MH370 story does not end here. This is just the beginning.